pleasure and honor to welcome you all for this international conference on new dimensions in chemical sciences and education. We are honored to join today by our distinguished dignitaries, including our Honorable Vice Chancellor, Professor Pillai sir. Because of his efforts and support, it is possible for us to come together today and conduct this international seminar. We are also gratefully welcome the eminent scientists and academicians, Professor Satyamurthy, Professor Gadre sir, Professor Sivaram sir, Professor Bhagwat sir, whose groundbreaking contributions continues to inspire and lead our scientific community. This conference brings together a vibrant network of more than 150 registered participants and faculty members. Over the course of these 3 days, we will witness 19 invited talks and more than 40 poster presentations and more than 40 oral presentations by the students and researchers, showcasing the depth and diversity of innovative research in chemical sciences and education. It is testimony of growing recognition that chemical sciences and chemical education are at the heart of solving many problems of today's world, from sustainable energy, environmental stewardship, to advanced materials, healthcare, and food security. And equally, it is shaping the minds of today's youngsters for solving tomorrow's problem. Somaiya Vidya University has long championed the integration of innovative research and education in an impactful teaching. The Association of Chemistry Teachers of Mumbai is a premier network of chemistry educators, has been instrumental in advancing excellence in teaching and education. This gathering is a remarkable opportunity for learners through thought-provoking discussions and collaborations. Among academicians, leaders, educators, and industry professionals, and young teachers, let us use this forum to share our knowledge, foster the new ideas, and forge meaningful partnership that shapes the future chemical science and education in India and abroad. With these words, once again, I extend my warm welcome to each one of you. May this conference be intellectually stimulating, professionally rewarding, and personally memorable. Thank you. Let us look forward for successful iron learning conference. Thank you.
Thank you, sir, for setting the tone for the conference with your warm welcome address and giving a brief overview of the conference. To share the vision and objectives of the conference, we shall now have the address by Dr. D.V. Prabhu, President of the Association of Chemistry Teachers and convener of the conference. A renowned academic and researcher, Dr. Prabhu has served as Dean of Science at Mumbai University and Head of Chemistry at Wilson College. With over 70 publications and several prestigious awards, his contributions to chemical education and research are indeed widely recognized. We are honored to have you with us, sir. I request Dr. Prabhu to kindly address the gathering.
Dignitaries on the dais, dignitaries in the audience, delegates, my colleagues, ladies and gentlemen. Good morning, and I wish you a very fruitful conference. On behalf of the Association of Chemistry Teachers of India, it is my privilege to welcome you to the International Conference on New Dimensions in Chemical Sciences and Education, which has been organized in collaboration with Somaiya Vidya Vihar University, one of the most prestigious universities of our country. Started in 2000 at the initiative taken by the Homi Bhabha Center for Science Education, TIFR, the Association of Chemistry Teachers has come a long way, starting with the blessings of our founder president, Professor N. Satyamurthy, and successive presidents, Professor Gadre, Professor Sudha Jain, Professor S.D. Samant, Professor D.C. Deka, Professor Brijesh Pari, and so many others. We have a large network of active members and institutional members all over India. Coming to this particular conference, This is the flagship activity of our Silver Jubilee, and I am grateful to the Honorable Vice Chancellor, Professor Rajshekaran Pillai, and all his colleagues for their tireless efforts to plan and organize this conference on such a grand scale. We are grateful to you, sir, for your help and support at all times. The Association of Chemistry Teachers has organized this conference, keeping in mind the needs of the today's chemistry community. We have a galaxy of speakers from India and abroad, speaking on a variety of new frontier areas such as green chemistry, then computational chemistry, new materials, nanotechnology, and environmental chemistry, metal organic frameworks, MOFs, so on and so forth. There are special sessions on experimentation in chemistry, then entrepreneurship, the Chemistry Olympiad program, and so on, which will appeal to those who are working in the field of chemistry education. The conference has received more than 90 oral and poster presentations from all over our country. These presentations represent the work done in our colleges, universities, research institutions, and industry. I can proudly say that the research work presented is of a good standard, comparable to the best in the world, and represents some of the most advanced areas of chemistry and chemical research done in our institutions. I'm very much thankful to our distinguished guests, Professor Sunil Bhagwat and Dr. Kamlesh Phondekar, for taking time from their very busy schedule to be with us. I'm thankful to you, sir. The Association of Chemistry Teachers is grateful for the generous support given by Godrej Group of Industries. Dr. Kamlesh Phondekar is here. Jan Rashid Consultants, represented by Dr. Marzaban Karai. Green Chemistry Foundation, represented by Dr. Krishna Padia. The Chromatography Society of India, represented by its president, Dr. G. Ramakrishnan, and the Indian Chemical Society, represented by its president, Padma Shri G.D. Yadav, who is the president of the Indian Chemical Society. This conference is an opportunity to interact with the most eminent chemistry experts in India and abroad, and we are having experts from academia and industry. So let us make the best of this golden opportunity. I once again welcome all of you and wish you 3 fruitful days of interaction with the eminent faculty of the conference. Thank you very much.
Thank you, Dr. Prabhu, for that insightful briefing of the vision and purpose of the conference. As we commemorate the Silver Jubilee of the Association of Chemistry Teachers, it is a true honor to have with us Professor N. Satyamurthy, the founder president of the association. Professor Satyamurthy is a renowned theoretical and computational chemist and is currently the INSA Distinguished Professor at IISER Mohali. He was the founder director of IISER Mohali and has also led the Chemical Research Society of India as its president. We are indeed privileged to welcome Professor Satyamurthy to share a few words about the association on this special occasion.
Thank you, madam. I must thank Professor Prabhu for asking me to be here. I'm grateful to Professor Rajshekaran Pillai, the Vice Chancellor of Somaiya Vidya Vihar, for inviting us and for hosting this meeting. I'm delighted to have other friends on the dais and off the dais. It's my privilege to be standing in front of you, partly because I had the privilege of being the founder president of the Indian Association of Chemistry Teachers. A few words on the origin of it. Before what is called Association of Chemistry Teachers, the word Indian had to be dropped because somebody else had registered the name. And before that, there was Indian Association of Physics Teachers. In some sense, they are the parental association for the Association of Chemistry Teachers. I remember the then President Wagmare said, we must start with the Indian Association of Chemistry Teachers. Professor Arvind Kumar used to be the director of the Homi Bhabha Center for Science Education, TIFR, in Mumbai. And he was doing many things. One of them was spearheading the Olympiad movement and had agreed to host the International Chemistry Olympiad in Mumbai. And in that context, I think there was a drive for setting it up. They wanted to set up an association of chemistry teachers who would conduct the national test to select the candidates for the National Olympiad. From that, a small team would be made for participating in the International Chemistry Olympiad. And that particular year, 25 years ago, India was hosting the International Chemistry Olympiad. Some of the colleagues who were there, part of the team, are there in the audience, and Dr. Prabhu, of course, was there. He was from Wilson College. And this team, Professor Gadre, Professor Uday Maitra, and others, took great initiative and participated in this exercise. And needless to say, India did a good job, and our students did a fantastic job, got silver and gold medals. And the tradition continues. Every year in the month of August, you hear about our students doing very well in Physics Olympiad, Chemistry Olympiad. Now there are so many Olympiads. Physics, Chemistry, Mathematics Olympiad was always there. Astronomy Olympiad, now there's a Biology Olympiad, etc. So this was the context in which the Association of Chemistry Teachers was formed. The Association of Biology Teachers followed subsequently. And I must say one thing special here. Professor Prabhu from Wilson College was playing an active role, and he agreed to be the secretary of this association. After me, Professor Gadre kindly agreed to be the president, and after that you heard several names from all over the country who had been president of the Association of Chemistry Teachers. It is a wonderful thing. Two things. Number one, on the Silver Jubilee occasion, I congratulate the Association of Chemistry Teachers for having completed 25 years, and also congratulate Professor Prabhu, current president, for the same. And one thing remarkable about Professor Prabhu is that he has been working with and for the Association of Chemistry Teachers. As I said, he started off as the secretary and continued for last 25 years. I will say remarkable. In some sense, nobody in his right mind would agree to do that, but it is his selfless effort in spearheading the organization, holding it together, and finally agreeing to be the president in this Silver Jubilee year. Prabhuji, I thank you for the same, and I congratulate you for the same, and I wish you and your team all the best. Please join me in this endeavor. Thank you once again.
Thank you, sir, for providing the historical perspective of the association. Your inspiring words will surely be a source of encouragement to the torchbearers of chemistry, science, research, and education assembled here today. We now have come to a truly special moment of this inaugural session, the address by our patron, Honorable Vice Chancellor, Professor V.N. Rajasekharan Pillai, a towering figure in Indian academia, an eminent researcher, and a visionary leader in the field of education.
Good morning, everybody. First of all, let me, on behalf of the Somaiya Vidya Vihar University and the entire Somaiya Vidya Vihar chemistry fraternity, welcome the delegates for the International Conference on New Dimensions in Chemical Sciences and Education, organized by Indian Association of Chemistry Teachers. I am extremely glad that the Somaiya Vidya Vihar University got this occasion to host this conference. Dr. Prabhu, Professor Satyamurthy, they have all mentioned about the origin of this association 25 years ago. Let me congratulate the members of the Indian Association of Chemistry Teachers, the very best in their efforts towards furthering education and research in chemical sciences in the colleges and the universities in this country. You will be hearing the various presentations. I am here just to welcome all of you on behalf of the university, just saying a few words about the university. Somaiya Vidya Vihar has been in education for the last 83 years. We are in higher education for the last over 60 years. As a university, as a self-financing university, we are just here for the last 6 years. If you just look at the chemistry presence in the Somaiya Vidya Vihar system, you will see we have several undergraduates teaching in chemistry in our Science and Commerce College headed by Professor Prajna Prabhu. Postgraduate courses in 4 different branches in that college for the last several decades. And then in the university, we have a polymer science program, polymer chemistry and polymer science program. We have also started several initiatives, and then recently we have started an MSc in chemistry as part of the Faculty of Engineering to start with, but it is definitely a university department. We have MSc students. A good number of students have joined for the MSc chemistry program with green chemistry and applied chemistry as some sort of electives. Then we have also created facilities specifically for research connected with chemistry. For example, the pyrolysis unit supported by Frontier Laboratories Japan, initiated by Professor Shivaram, who is sitting here, who is Professor of Eminence with us, who has been guiding the science Faculty of Science for the last 4 years, ever since the university started, since promoting science education and research. And then we have also a center for, it is called C2S2, Center for Computational Science and Simulations, again with industry academia collaboration chaired by Professor Sridhar, the scientific advisory committee to that unit is chaired by Professor Sridhar Gadre. We have a Shimatsu Somaiya Center for Measurement and Analytical Sciences and Measurement Sciences, jointly instituted and established and run by the Shimatsu Corporation Japan and the Somaiya Vidya Vihar University. And we are also thinking of, several initiatives to promote science education in a holistic perspective. We have several other initiatives. Of course, if you just look at the university, we are engineering, management, humanities and social sciences, languages and literature, music and performance studies. It is a multidisciplinary university, not just certain professional areas, multidisciplinary universities. If you have a school of art, of course, we have also a school known as Thwani Chitram, that is a film school. Thwani Chitram, a film school supported by the Bombay film industry. So this university is definitely has to now concentrate more on strengthening science education and research. And several such initiatives, several such conferences are happening in all different branches of science in this university, just to promote our researchers. We are also supporting research scholars in a very significant way with junior research fellowship at the national level. The amount is a little bit more than the national scholarships. We have good number, over 58 JRFs have joined in this university. We have created 100 JRFs and several postdoctoral fellowships, but of course, we have been seeing that the takers were few, but now things are getting improved. And therefore, conferences of this kind gives us an opportunity to interact with our own faculty, and also to experience the ambience of, experience the system of other institutions which have come up in science education and research. And chemistry, of course, you know that chemistry is a major area of education, higher education and research in this country. If you just look at premier institutions, somebody was telling from the IIT Kanpur, the chemistry department, almost all the persons from IIT Kanpur sitting there, Professor Sridhar Gadre, Professor Shivaram, Professor Uday Maitra, and of course Professor Satyamurthy. They are all here. They are all professors of chemistry, originally coming from the IIT Kanpur, started by Professor chemistry department headed by P.T. Narasimhan and Professor C.N.R. Rao, Professor M.E. George. I mean, of course, they are the like. And today we have all the doyens of chemistry here. Now, the director of ISER Pune, Professor Sunil Bhagavat, is the chief guest of today's function. And he has also visited this campus. This is your third visit, Professor Sunil Bhagavat. Let me welcome him. And of course, let me also welcome the guest of honor, Dr. Kamalesh Vandekar, Head R&D, Godrej Agrovet. This university has been effectively interacting with the chemical industries in a very significant way. Today evening also we are going to have a function related to that. So good number of industries are coming to this university for supporting chemistry research in different areas. We have a program nationally now very well known as VChemi. I think I saw the students, several students, they are here in the campus. VChemi, that is a scheme supported by the industry, chemical industry, to enhance the presence of women in the industrial floors of chemical industries. It started with a CSR support from BASF. Now several other companies are coming to support this initiative. We identify, final year BSc chemistry students, or students who are studying in MSc chemistry across the state of Maharashtra in the first batch. Now it is across the country. We are getting students, girl students, and we provide them training for almost 45 plus 45, 90 days intermittently without disturbing their classes. Industries are supporting. They will visit to the various industries, and this is the fifth batch. Now it's going on. All of them are placed. All of them are placed in the industrial industries in the western region of the country. So we just think about a lot of other initiatives to support chemistry education, and then quality. Quality in chemistry education is very important. I have seen. Of course, basically I am a chemistry teacher. So I have seen that the number of students opting for chemistry in the very strong colleges from the state which I am coming from, Kerala, it is coming down. And that is the case with several other states. And therefore, it is very important that we have to look at chemistry education and strengthen it, and probably find out the loopholes, and then try to promote the chemistry education in a very significant way. And I'm glad that good number of industries are also participating or supporting this particular event for the last several years. And we welcome all the delegates from the industry also. We have some international participants also, for the international speakers also for this conference. Let me welcome all of them. And I see Dr. Jayaraman from the ARC sitting here, a powerful science communicator. He has been interacting with our science communication and media. And we have let me congratulate all my colleagues, Dr. Rupmi Tarkar, our Dean of Students, and the Dean of Faculty of Science, and all my colleagues from the Department of Chemistry of the College of Science and Commerce, as well as the university departments, for making this event a successful one. And let me once again welcome all of you to the university. Please experience the ambience of this institution, and this is a multidisciplinary university. We welcome all suggestions from the eminent teachers how to probably some sort of a refinements which are necessary for chemistry education. We look forward to recommendations from this conference. Thank you very much. Once again, welcome to the Somaiya Vidyavihar University.
Thank you, sir, for your insightful and informative words and continued encouragement and support. We shall now proceed to a meaningful moment of honor and gratitude, the felicitation of our distinguished guests in recognition of their presence here and their significant contributions to science, research, and innovation. I request our Honorable Vice Chancellor, Professor Rajsekharan Pillai, to kindly felicitate our Honorable Chief Guest, Professor Sunil Bhagwat, Director, ISER Pune. I now request Professor Pillai to felicitate our Honorable Guest of Honor, Dr. Kamlesh Phondekar, Head R&D, Godrej Agrovet, Mumbai. We are truly privileged to have such eminent figures amongst us today. Thank you, Professor Bhagwat and Dr. Phondekar, for gracing this occasion and supporting our shared vision. We shall now have the official unveiling of the conference souvenir, a token of the event's vision, efforts, and collective contributions. I invite the dignitaries on the dais to kindly do the honors of unveiling the conference souvenir. Thank you, respected dignitaries. We shall now proceed to the address by our esteemed chief guest, Professor Sunil Bhagwat. Professor Bhagwat, Director of ISER Pune, is a distinguished academic, researcher, and mentor in the field of chemical engineering. He is renowned for his pioneering contributions to interfacial science, artificial neural networks, and engineering. With numerous publications, patents, and prestigious awards to his credit, Professor Bhagwat truly embodies excellence in both academia and industry collaboration. It is my privilege to now invite Professor Bhagwat to deliver his address and officially declare the conference open.
Dr. Prabhu, Professor Pillai, Satyamurthy, Dr. Phondekar, and the Dean, Dr. Desai, distinguished dignitaries in the audience. I see Professor Gadre, Professor Shivram, a gathering of people who are quite senior to me. It's an honor to stand here as a guest and address the teachers
of chemistry. How many of you are chemistry teachers with less than 3 or 4 years into teaching? Anybody? Okay, just a few, all right. And how many are chemistry students? And by that I don't mean, even I will say I am a chemistry student lifelong, but degree students, yeah, okay. Thank you, thank you. Why I was asking for this is, when I was told that I am going to address Association of Teachers, I was wondering what I should talk, and I saw the title. It was very tempting to talk about some of my recent research work and outcome of that. But then I felt that such research outcome is of interest to a narrow few. So why don't I try and talk to all the teachers and share some of the experiences that I have had as a teacher and see if I can get something from all of you as well. One of the first things a chemistry teacher faces is that when the students come to a class, the notion that they come with from their home, chemistry, oh, all those fumes that are coming out from the chemical industry. Because when you tell a child to draw a chemical industry, the first thing the child will draw a building and some fumes coming out. Then the parents think, oh, you are going to deal with dangerous materials. So is it really good for you to be doing chemistry? And the students have come despite that for whatever reasons, and the teacher is expected to address them. So I thought, let me first dispel this notion that the world's pollution has something to do with the chemical sciences. If you ask which is the biggest pollution problem faced by the world, people will talk about global warming, climate change, and mainly the carbon dioxide. Very true. Let us see where that carbon dioxide comes out from. Apart from the biological activities of all animals, almost 50% or little more of that carbon dioxide comes from the stacks of the power plants. Is a power plant a chemical plant? No. Are the users of that product of that chemical or chemical science or chemical technology? The main electricity consumers line our homes with the common man. Today our electricity is 450 gigawatts. What is the other half of the carbon dioxide coming from? And remember, this carbon dioxide, the first half that I talked about, is common man's usage, this lighting, this air conditioning, everything that we do at home. And almost something to the tune of about 12 to 1500 units or kilowatt hours of electricity per person is spent almost uniformly, nothing to do with chemistry students or chemistry teachers. And the other half comes from vehicular pollution. I can say that the petroleum comes out from a petroleum plant, but had it not been for those petroleum products, do you know a story about 1900 that in New York it was said that the vehicular pollution in New York City has become so much that New York has now become unlivable, and any growth in the traffic in the city will make it impossible to stay there. There were no petrol or diesel cars at that time. The pollution that they were talking about is the horse excreta lying everywhere with the horse carts. Any of you who has traveled to Matheran would remember that all-pervading smell. Imagine if today's cars are all replaced by horse carts, what will happen? So the diesel and the petrol cars actually came as a solution to the pollution problem. Today we are using it to such an extent that that has itself become a pollution problem, agreed, and it's a cyclic process. Just because today we find that these vehicles are emitting carbon dioxide and that is causing a pollution, doesn't mean you go back and start using horse carts. A new solution has to emerge from science from mainly chemistry once again. And if at all there is any science or engineering branch which can look at abating the pollution created so far by this electricity or by this vehicular transport, which, by the way, everybody uses, not just chemistry people, who is the science that looks at abating that pollution? And you would realize that is nothing but chemical science. So if at all there is a role for chemists or chemical technologists about pollution, it's in abating it and not creating it. So that is the first thing. And the world needs to be thankful to chemical science for so many things. Let me give you, for example, if it was not for chemistry, 80 to 90% of the world's people existent today wouldn't have even come into existence. Again, going back to the 19th century, there were discussions that the entire land under cultivation is now reached a limit, and if at all we have to now convert agricultural land to NA for living. Even today we hear that so much. All the forests that we could have broken down to make into agriculture has run out. And if there is any increase in the population of the world will die of starvation. I'm talking about 1900. Then what happened? Fritz Haber happened. Fritz Haber came up with a chemical process that nitrogen reacts with hydrogen. Karl Bosch converted that laboratory process into a manufacturing plant. The reason for doing that was to make nitric acid to make the TNT bombs from the World War. But post the World War, that same ammonia became the nutrient to the soil which can produce 5 to 7 times more food from the same soil. And that is the sole reason why we all get to eat food today. Would it have happened had it not been for the chemical science? Had it not could have happened without the knowledge of what we say that higher pressure gives you higher chemical conversion in a certain type of reactions and so on, all that knowledge? It is simply such processes or such developments that make the world livable, but still the world's first reaction is chemists. They create pollution. Let me give you a more recent example, and just because we are Indians, I'm going to give you an Indian example where things got changed because of chemists' work. India needed to have nuclear energy. And when Dr. Bhabha and everybody started nuclear research and nuclear energy started becoming popular, India also needed the security through nuclear weapons. And 1973, when we had, 72 I think, the first Pokhran blast, the entire world reacted to it in such a way as if now we are going to come and attack the rest of the world. And they stopped supplying anything related to nuclear to India. And you all will know that one of the very primary things required for nuclear energy from uranium is heavy water, which is used for slowing down the neutrons so that the fission process takes place. And this heavy water, India had a supply of maybe few months with us. And I remember at that, in those early years, anybody wanted even an NMR, getting that D2O used to be a big process. And when world stopped supplying D2O to us, all our nuclear plants had to come to a standstill within months. That is when Indian chemists, and of course I am not denying the role of others, were thrown a challenge: can India make D2O? Now D2O is part of the same drinking water bottle that you hold. But the concentration there is about 150 parts per million. And when you want to purify that to a pure D2O, the challenge lies in how you can separate the D2O from H2O. And the separation usually is done on the basis of what is the difference in the property of two materials. Now D and H being isotopes, you all know that chemical properties are almost the same. Most common way of separating materials that industry will follow will be distillation. And for distillation, you look at differences in volatility. The relative volatility, if it is less than 1.3, 1.4, closer to 1, chemical industry starts looking for an alternative way of separation. Here, D2O and H2O, the relative volatility is 1.0003. One of the toughest separations that you can think of. And what is the ratio of purification? If we say that fermentation produces 4% ethanol, and if you want to purify it to 100%, it takes up a lot of energy, right? 4% to 100%, 25-fold. Here, we are talking about 150 ppm to pure. 7,000-fold purification of a substance which is 1.0003 relative volatility. No wonder India did not have the technology of how to do it. The challenge was thrown, and soon our scientists found that the same chemical reaction of nitrogen, hydrogen reacting, giving you ammonia, has a tiny, tiny preference to H rather than D in that hydrogen. As a result, the recycled hydrogen, because remember, it's only 20 to 30% conversion in that ammonia process. So the recycled hydrogen accumulates in deuterium. So instead of starting with 150 ppm, if I can start with, let's say, even 1000 ppm, the cost of purification is directly proportional to the ratio of purification. 150 ppm to pure is 7,000-fold. Even 1000 ppm to pure is just 1,000-fold. 7 times reduction in the cost of manufacturing. India soon developed processes. There are operating even today some of the fertilizer plants together with the D2O plants, heavy water plants, and we started making heavy water sufficient for us. And today, we are the largest manufacturers and exporters of heavy water to the entire world. Now, this technology was developed by Indian chemists, Indian chemical science people, and the world started taking notice of us. Of course, and later there are several examples in science, in other sciences. For example, when India was denied Cray supercomputer, we developed the Param supercomputer system. When India was denied space knowledge, we developed our own Chandrayaan, and today people talk about, wonder about how is it that India is doing it. The world is scared of denying anything to India if they ask. Because if we are denied, we will develop something by which the world will have to stand up and take a look. Now, all such developments, the first couple of them I mentioned were of chemistry only, do not happen without people taking chemistry and sciences seriously. Now, these are the points of pride for our students, that they should be coming to learning that science, not just for passing that examination. And when that happens, we would be really successful in making our students really students of chemistry rather than students for that examination. And just to complete the story about Fritz Haber, India did not have that development happening till much later. If you remember, India used to have droughts every time there was a famine, and people would die of starvation. Many of us have read books, again from 18th, 19th century, about such famines and people dying. And of course, the famous Bengal famine, which happened thanks to the British War, World War II, and the grains being taken for the soldiers. But again, after independence in 20 years, 3 years there was consecutive drought, no rains, and serious famine situation. And India had to import food, and food was given to us as an aid, as a charity, under PL 480 scheme by United States. Food which was unfit for human consumption, being fed to pigs in United States, was given to our ancestors. And we had to survive on that. And that humiliation, of course, hurt everybody, including our then Prime Minister, who made an appeal that 1 day per week, if you do not eat rice or wheat, our grains might be sufficient for longer. And many people started a fast. They called it the Shastri Somvar. And they took a vow that I will continue with this fast till the day comes that India gives food aid to United States. A tall ask. Something happened in between, and in 2003 or something, when Katrina the storm hit United States, and their entire part of New Orleans and a lot of region was inundated with seawater. Their food grains were lost, and India offered food aid because some of our ships of food were on the sea for supply, and they accepted the aid given by India. I remember there was a news item then, people in their 70s and 80s held a public function announcing that we are now stopping our Shastri Somvar. Who makes such incidents possible? It must, the only two words that we learn in school is Green Revolution, Harit Kranti. What happened in the 60s, post that famine, is that Shastri gave a call for Jai Jivan, Jai Kisan, and he induced our chemical sciences to start all those fertilizers, pesticides which were required for the country, which made us possible. Today we produce number 1 or number 2 rank in rice or wheat or sugar or peanuts or pulses. So many things we are either number 1 or number 2, and we export. And when Russia has a war with Ukraine, instead of Ukraine, the world starts looking at India as the food supplier. This level of change is possible with the field that we work in. I thought it is appropriate to give such examples just to make sure that this enthusiasm we can convey to our students in the classroom. And thank you for inviting me here and giving me an opportunity to talk to all of you. Thank you.
Thank you, sir, for sharing your experience as a chemistry teacher, dispelling myths about chemistry, highlighting the beneficial applications of chemistry, and most importantly, highlighting the contributions of India. Thank you, sir. We shall now proceed to the address by our esteemed guest of honor, Dr. Kamlesh Phondekar, Head of Research and Development at Godrej Agrovet. With over 3 decades of techno-commercial expertise, Dr. Phondekar is a visionary leader in applied research and sustainable agricultural innovation. Holding international patents and with an extensive portfolio of publications, he continues to successfully bridge the gap between scientific research and real-world applications. It is my pleasure to invite Dr. Phondekar to address the gathering.
Thank you. Respected Professor Pillai, Professor Bhagwat, Professor Prabhu, Professor Satyamurthy, Professor Desai, the distinguished guests here, teachers and students. Right. It's my pleasure to be part of this international conference on new dimensions in chemical sciences and education. And basically, if you really see, the chemistry is evolving. Professor Bhagwat talked about the historical stuff from the ammonia production to the urea to the green revolution. And we are continuously evolving, right? Why are we really evolving? Because we need to change. These are the requirements, right? Again, a lot of new research is in progress, right? The newer areas are arising from this research. There are technological changes. Professor Bhagwat mentioned about it. We need those technological changes. And now we are also looking at the sustainability, right? Professor Bhagwat talked about the carbon dioxide, but we are really looking at, we are getting more and more involved in the sustainability. The green chemistry is really taking a very big shape, which really forces us to be really looking at the new dimensions, right? These are the newer dimensions of the chemistry, what we are talking about. Now, what do we need to get into the new direction? We need new breakthroughs, yeah, with a sustainable chemistry. Yeah? We need to really integrate the newer technologies, because we talked about the artificial intelligence, machine learnings. Can we really incorporate those in our daily research and things and bring it in, right? And then we look at materials, molecules for the newer applications. They already exist, but can we really find the newer applications, take it to the next level? How do we do it? Very difficult, right? And that's where we need a bridge between academia and industry. This is purely because the chemical industry is going to grow, and we cannot do the same thing what we are doing it. If we really need to grow by say 2040, we will have at least 15% of our chemicals produced in India. So this means we definitely need change. It's not only the scale, but we also need to look at the quality. How do we really bring in the innovation to address these issues, right? And therefore, it's important to embrace this into our innovations. But at the same time, it's also important that our academia is also taking the important role in this. And therefore, it's important that the industry, academia come together, work together to address these issues. Professor Pillai mentioned about the various programs being done in Somaya, talking about the advanced material, looking at the newer polymers, self-heating polymers, newer batteries. We talk about the electric vehicles, where we require the batteries. We talked about the computational chemistry, absolute essential to discover new molecules. Professor Satyamurthy is here, right? We talk about the green chemistry, which is essential part, but also the chemical biology. We are really, as a chemist, we cannot afford anymore to look only at the chemistry, but we need to look beyond the chemistry to the adjacent, other faculties of sciences as well, whether it's AI or chemical biology. Professor Bhagwat mentioned about the agricultural the progress what we made. But looking at the newer science, what we really bring in, earlier for agrochemical, typically we used insecticide about few kgs per hectare of the land to make the a better quality products, right? We needed increase the yield. But look at the today's science. You require a few grams of the products to make it sustainable. So this increases your sustainability. You require a lesser chemical to give the same yield or a better yield. How this is possible? This is possible provided you understand the mechanism of the biology, you understand the biology of the pest, and you start targeting the specific molecules with the specific targets. And these are the changes, but you will also need to do a lot of biology along with the chemistry. So it's all the chemistry, but also needs support of the biology. And now you can take help of the lot of computational chemistry with the help of AIs and machine learning. These are going to be the key for us to bring in. And then we also have a technological advancements, right? Right. For example, we manufacture products for several years. We have several products. We had a batch processes. Now, a lot of changes we have seen. The batch processes are getting converted into the continuous chemistries, right? We knew nitrations were done in large scale for several years, but people are really moving, not doing a nitration in a batch. Can we do it in a safer way? Can we do it in a flow chemistry way? You have a much fantastic safety, you have higher quality products, you are ascertain with lot of things here, right? So this is the evolution of the chemistry what we are talking about, yeah? And this is exactly important from the landscape perspective, and this is what our new dimensions are talking about. But at the same time, what we need is a changes in the curriculum as well. A lot of chemistries have been taught, but if we really want to move in a new direction, we really need to introduce the industrial training into the chemistry teaching as well, right? So can there be a better partnership between academia and industry? Can really students can go and work in CSIR labs or IITs? Can they get a trainings there? Can they come to the industry, spend time in the industry to understand what's really happening? So it definitely needs to be more integrated with the industry requirements. So if you really want to do discoveries, bring this to the application, to the public, we definitely need to do that, right? So for this, we definitely require interdisciplinary collaboration. I talked about the chemistry, whether it's a biology, learnings from the artificial intelligence. These are the important things, right? Along with that, we spoke about the green chemistry. And every chemistry, what we look at from in industry, we really look at can we really apply the principles of the green chemistry? The classic, ways of doing chemistry is taking a back seat. We look at atom economy now, right? So we are worried about every atom, really what's happening? Can I really get converted into the products there? Those are the things which are really changes taking place. But this is a shared responsibility for us to take this forward. Yeah? So neither industry, nor the academia, nor only students, nobody can do it by themselves. And therefore it's important to have the shared vision for this, right? Can we really do the co-innovation, right? We need a platforms to do the co-innovation, whether the academia, industry. We require a curriculum in the academia and industry going together, right? And we also need a entrepreneurial ecosystem, right? So are we really looking at the student and teachers commercializing their innovations, right? So that's very, very important for us. So I'm not taking much time, so looking at the newer dimensions in the chemical sciences and education, the students here, they have real opportunities. There are really problems, and this gives them the challenges and opportunities to resolve the problems. And this is an apt, basically, conference for all of you guys to really come together and address the challenges of the future. Thank you. Thank you very much.
Thank you, sir, for emphasizing how the new developments and innovations in chemistry and its integration with other sciences can be channelized towards a sustainable development. As we near the conclusion of this inspiring inaugural session, it's now my privilege to invite Dr. Anant Kulkarni, convener of the conference, to propose the official vote of thanks to acknowledge the collective efforts that have brought this landmark event to fruition.
Thank you, Dr. Jacinta, for that, all this comparing done so far in the morning session. Good morning, all of you. Respected dignitaries on the dais, Honorable Vice Chancellor, Professor Pillai sir, Professor Nitin Desai, Professor Satyamurthy, Professor Bhagwat, Professor Prabhu, and Dr. Phondkar. Other respected dignitaries which are present here, Professor Shivram, Professor Gadre, my mentor, Professor Uday Maitra, and my team members. It's a rather difficult task to express this vote of thanks at this giant gathering of eminent speakers, eminent scientists in our country and abroad. This is joint efforts of Association of Chemistry Teachers India and hosted with the help of Somaya Vidya Virahar University. All the team members who were the part of this organizing committee and the conference you will be having for next 3 days. I'm indeed thankful to all of you for gracing this conference from bottom of my heart. I welcome all of you from Somaya fraternity, Somaya Vidya Virahar University fraternity. My other team members, without their help, I'm in particular thankful to Dr. Urmi Thakkar, Professor Prabhu, Pradnya Prabhu, Principal, KJ Somaya College, Dean Sir, without all your efforts, the beginning and performing this type of scientific program is simply impossible. Once again, I thank all of you, and in particular, I would like to express my gratitude to our Honorable Vice Chancellor, Professor Pillai, our mentor, Professor Shivram, who is like a father figure for all of us here on the campus. He is in fact the mentor of the Polymer Science Department, to which I am associated, also the mentor for the Center for Computational Science and Simulations. While being on this campus, I invite you to take a walk on the campus, feel the vibrant nature of this university, where my mentors, Professor Pillai, Professor Shivram, Professor Gadre, who are trying very hard to establish a vibrant scientific culture in multidisciplinary university over here. So I welcome all of you. Take a walk, experience this thing, interact with everyone. We'll be happy to give you more insights of Somaya, and I expect we'll have many more occasions for such type of scientific events with the help of collaboration of ACT and all of you. Thank you all, and let me officially tell you that we'll break for tea for another 25 minutes. Let's join back, and it will be taken over by other chairs. Thank you all, especially all the dignitaries. Thanks for your support. Thank you everyone for joining for this conference.
Thank you, sir. As announced, we shall now proceed for a short tea break. Tea served in the foyer at the back of the auditorium. Requesting you all to kindly assemble back here by 11:30 a.m. sharp without fail. preferably before that, for the much anticipated talk by Professor N. Satyamurthy. You may exit slowly once the guests leave the dais.
We'll have a group photo of all the participants over here. So please join us. Excuse me, the photo will be taken just at the adjacent steps over here. So we go out from this gate and then get on the steps over there. Okay, my volunteers will help you.
HDMI, na?
Yeah.